Welcome to the final instalment of I took a control panel apart. I was showing you what all the bits are, but now I need my bench back and I need to fuck them all off, so I've got to finish this video because I want this area back for doing the jobs I've got to do in it. So let's continue looking at these control panel components. If you're on YouTube, you'll still be continuing. How'd that move on its own then? Anyhow, you'll still be continuing because this will be one long video of bits. We've done that. That's here still because I'm trying to make it run Doom. So that's not leaving the workshop because I want to make Doom run on that. Anyway, let's look at something we haven't looked at from the remaining bits. Get the big one out of the way first. This is an absolutely monstrous power supply by Siemens. It's from this stooped range. Fucking incredibly expensive. Also incredibly rugged and incredibly versatile. And as you're about to find out, look, because of that little thing over there, part of the system they do. This particular one, it's three-phase input, look. Let's focus. So it's three-phase only. You can't put single-phase into it. It's three-phase only. Is there anything on the top? There's a lot of gear in there, look. A lot of three-phase transforming gear. A lot of space to get the heat out. These are... I've never seen a broken one of these. It's a 24-volt, 40 amp, which is an absolute beast of a power supply. And all you've got to do to it is put in three-phase, no neutral, just the earth. It's got a little adjustment to get you to bang on 24 volts. It's got the outputs. The 40 amps at 24 volt DC is massive. And then there, look, you've got a contact for DC OK. So if it's working out, it should have putting out 24 volts. That'll close. And that's it. Even though it's a chunky beast, there's nothing more to say about it except they're incredibly reliable. It's 40 amps, which would take your fucking face off. It's got an alarm contact. It's got three-phase in, so I won't be using this anywhere. This would just be a hot spare or an example. And it's part of a system, so we'll look at the rest of the system now. Start with that fellow over there. Stood up. Is it stood up? How do you spell that? Stop. Side up. Side up. This will also be incredibly expensive just because it's from this particular Siemens range. This is part of that range. And this is a DC. Look at the size of those connectors. Chunk look like ear vents, but they're actually connectors. This is a DC UPS module. Uninterrupted power supply module as part of that stick-up range. And basically all you've got on here is, look, you've got your POS in, your POS out, and your battery. Because what you do is you put your 24 volts DC from your power supply through this, and then you put you take your 24 volts out of it, and then you put batteries in it as well. And that means even if the power supply explodes and destroys itself, the supply is never interrupted, hence the name uninterruptible power supply, because it just then takes off the batteries. This has some other features. Let me just check this out, one sec. I've had to work on one of these before, and I remember they had a lot going off. So here, look, you've got like various alarm settings. You've got an OK light, a battery fault light, an alarm light, and a battery less than 85% light. Then you've got this. So I think these are ratios, like, you can set the battery up, set the battery thingies, look, so like, you can basically set the parameters of the battery up and the voltage is up there. Then you've got some sort of time thing, seconds, aren't there, alarms if the time's gone off, and on and off, and other functions. Anyway, you've got loads of functions set by dip switches, which is crazy because now it'll be software. Here you've got all the alarm outputs, so you've got whether the battery's okay, normally open, normally closed, whether it's an alarm, normally open, normally closed, whether the battery's at less than 85% of its charge, and then you've got some on-off contact there. Dip switches for all the settings, like I said. There's the input, there's the output. The weird thing about it is, let me show you on the side just here. Look at the label, look, you'll see it's got a DC input of 24 volt, which can handle 42 amps. The output 1 can handle 40 amps of load. And output 2 wants 2 amp of battery. Is that the battery charging? Output 2. That's the batteries. I don't know if that's for the charging. I don't know if it can handle 40 amps of load and charge it. I think it can handle 40 amps of load and charge the battery at 1 to 2 amps. Or it's got a secondary output of 1 to 2 amps that just comes off the battery. I'm not really sure. Like I say, if you want to follow it home, there's the code, or follow on at home, there's the numbers. Look, do some own working out. But yeah, it's basically a UPS module. And if you don't want to use your 24 volt UPS, if you don't want to use your 24 volts so you can shut down safely or keep your comms on, That's what you need. You don't need that one though, but these are all very expensive, but that one's particularly expensive. So yeah, Siemens sit-up range UPS module. We're thinning them out now. We'll go for this. These are often found in control panels. It's just a DIN mounted socket. They're quite popular, and you can get them in the British version, in the best plug in the world, the UK version. That is a Socko Type F, which accepts a couple of other plugs, like it'll accept the Euro plug. The Euro plug is not the Socko. The Socko is the one that has the earth pin in, and these earth tabs here, look at the top and the bottom. The Euro plug's just a 2-pin non-reversible plug up to 2.5 amps. This one's 4 amps max. You'll find these always in control panels because they're plopped in control panels for the commission engineer. So there's always someone to plug in your laptop, so you ain't got to start training leads around that. It's quite a nice feature that they'll put in. Only costs a few quid, but it's always quite nice when you've got to plug a laptop in to be able to plug one of these in. You'll tend to find it's well worth carrying one of these adapters around because most control panels you come across, well, I come across from machinery, are often this type, but that'll quite happily accept an adapter. Power your laptop up. Don't plug your hair straighters in. One little trick to watch out for is sometimes these aren't 240 volt, even though they are designed to take 240 volt. Most laptop chargers will work at 100 volts to 240 volts. So sometimes in control panels you'll find these, and you plug a charger in like a DeWalt charger, and they'll charge the battery up because it's not all in 4 amp. And then you're like, why the fuck isn't this working? And you realise that they're actually wired to the 110 supply of a transformer. So although they are lighting it up, the voltage is insufficient short. So just watch out. These may say 4 amps on, but because they're for laptops, if they're in a control panel usually, it never specifies the voltage. The voltage goes anywhere between 100 and 230 volts. So yeah, if you are pulling that stunt, be aware that is a thing. In the box you go. We'll get it thin now. We'll do this one next. This is the temperature probe, and it's got a screw. Let me take the screw out of that and we'll have a look. It's definitely a temperature probe because it's got some sticky out anal probing. Does it say on the side? There you go. It's a 4 to 20 milliamp output, look. So it's a temperature probe that does from minus 30 to plus 60, and along that range it's got a 4 to 20 milliamp output. So neg 30 will be 4 milliamps, plus 60 will be 20 milliamps. And I'm guessing that that's a PT100 sensor, I reckon. Probably a 2 or 3 wire, or maybe even a 4 wire, who knows. Probably a 2 wire, I reckon, at a cost effective like this. And it will have some gubbins in here to convert it via analog signal, but it'll be part of the loop, so the voltage will be part of the loop. Let's do it and find out, see if I'm a clever bastard or not. With a screwdriver. So yeah, as I said, it's a loop power instrument, look. It's a 2 wire. I bet you that's a PT100. Fall over then, be a dick like that if you want to be. Be a dick. Oh, there's the drawing of a lid, look. So the lid says, oh, there's a lot more to go out there. Let's come back to that. But yeah, it's a PT100, I'm guessing, that converts it on this board to various outputs that a PLC would like to read. You can read a PT100 sensor, or you can read any temperature sensor if you like with a PLC. But most PLCs, as standard, nowadays have 420 milliamp or 0 to 10 volt analog inputs. If you want to buy a card that does temperatures, that's fine. It will save you buying expensive things like this. However, you'll have about 20 inputs, and they probably only want 1 or 2 on this thing, so it's cheap to buy this external thing that converts the temperature directly to 420 milliamp for the PLC to read. It won't be very accurate, but it'll just do the job of reading temperature to 0.1 degree. I might go full big Clive and take the board out. Let's do that. Wait there 1 second. This is an excellent quality product just because of the amount of information that's in here. Now, the information has been worn off. For some reason here it's worn off. See how small it is as well, look, but it tells you there, look. It tells you the layout of the things. I can't quite see that. I have to get a magnifying glass, but it says you can do 0 to 10 volt output. You can put in 15 to 30 volts DC and give it a 0 to 10 volt output if you do it in a certain wiring location, which is dead hard to read. And you can do a 7.5 volt to 30 volt input and get an output of 420 milliamps in 2 other terminals. And then it tells you there, look, you can use a 2 wire if you link those out like that, a 3 wire, which is more accurate, a 4 wire, which is the most accurate, or you can do 2 separate PT100 sensors there. So that's a really good bit of kit. Clearly German, clearly very well engineered. I'm going to take the board out and look at that. So it's interesting because it's got all these isolation slots. It's very, very well manufactured, this is. It's a great find, this, not for using again, but because it does, because it supports 0 to 10 and 4 to 20, it's ideal for lobbing in. I've got a Chevron new current source simulator. It's ideal for lobbing in there to check your wirings right. So that does both 0 to 10 and 420 milliamp reading and creation, syncing or sourcing, basically. So I'll lob this in with that because it's a great way of demonstrating it. So I'll demonstrate this further in another video. Now I've got something to show on the meter, but that PCB, so well manufactured. Let's get it out of a nose. When you've got slots like that, you know you're on something that means business. Not much point of taking it out, so there's not much to see. You've basically got you've got a ground plane, that's the ground plane. It's a two-sided board, as in this conductor's one side and the other side. And the back of it's just acting as a ground plane, really. There's a couple of traces and a couple of vias. They're the little tubes that... See those little tubes there, look? They get that trace from this side of the board to the other side of the board. So a couple of vias, a ground plane, and a few connections. So no really point taking it out. Let's look at this other side. So what you've got here is, you've got the terminals coming in that can handle 0 to 10, the common, and 4 to 20. Because it then have a voltage coming in, you've got there, look, that's voltage regulating. That's why it's got these slots in here, because somehow the voltage gets over there. And I'm sure that's a voltage regulator. I'm absolutely sure it's a voltage regulator. So that'll produce 5 volts, I'm guessing, for use on the board. Yeah, because the power comes in there, look, for a decoupling capacitor. Is that an inductor or a diode? For an inductor or diode, comes along there and goes into that, and then that'll produce a 5 volts for use by this microprocessor, which I'm guessing does the maths of the calculation from PT100 to the temperature rating. So does the maths between the 0 to 10 volt and the 4 to 20. I also think, see these pins, you might do to think those pins there, that set of pins and that set of pins, look, are for jumpers. They're not jumper pins, they're pogo pins. So basically what happens is when they've made this board, see how it's coated, everything on it's varnish, it's got a conformal coat on. So basically, the electronics, if you put on your finger on there now, there's an insulator. That's what that shininess is. So I'm guessing what happens is, they make this up at a PCB factory. They add on the whatever sensor you want, because it shows different sensor places, but there's 2 pins over there, look. So you put the pins on, then I'm guessing you slide a programming lead onto these that then let you program that chip however you want it. So if they have to send one out that's a different range or a different temperature rating, they'll just flash those pins up with the right program and send it out. Hopefully what will happen is, someone like Mike's Electrical Stuff will watch this video and tell me how wrong I am, or hopefully I'm right. But yeah, loads of decoupling capacitors, it's all varnished with the conformal coating, loads of inductors and stuff there, look. So they'll take that and yeah. I don't really know how these work. It's not married on my bag. Like I say, hopefully Mark's Electrical Stuff watches and tell me, give us the full ins and outs in the comments, or absolutely take a picture of that and tell us how it totally works. But yeah, clearly a very high quality product. But yeah, these will be programming pins, so don't ever start putting jumpers on them because you'll fuck it up. But yeah, clever device just to get temperature to an analog value for a PLC to read. Saves you buying a whole card for 1 or 2 values. Nice, I'll be keeping that. It's a nice bit of kit. These are both interesting and useful. You'll recognise these. These are just bog standard terminals, look. So they're the clip-on side of the DIN rail. They're the side that takes the wires in and out. And you'll see on this one, look, for example, these 2 top ones linked together and the bottom ones linked together. But you've got that weird socket in the middle, look. Can you see it there? So these go to that pin, and they go into that pin. So at the minute, all these do short out the top, short out the bottom. And there's a socket there, and that is for these, look. You can get these, which are insanely useful, but I never really have much use to use them. So if you've got to put a diode or resistor in, or fit some electronic component that's in that form factor, like that, look, you'll see there, look, they've put their resistors in there, and it's just took it to a terminal, because we don't want to do electronics inside control panels. And basically what you do is you flip this open on the side to put it in. Let me unplug this. This unplugs look like this. So that unplugs, I will get it on camera, there you go. That unplugs, let me undo one up. I can't actually get it open. I've got a sneaky suspicion that you put a screwdriver in there, look, so it shows the screwdriver. And I think, oh, you put the screwdriver into 90 degrees, 1 second, I just read that now, look. I see it through the camera better than came with my eyes, hang on. So what you do is you put the screwdriver into 90 degrees, look, and then you pre-bend your legs like that, look. And then what happens is, without a tripod, is you then basically place this in here. It's basically like a Wago style terminal. When you put that in there, look, that goes in, that turns out, and now it's grabbed that. So yeah, it's basically, that's how you put your component in. Extremely useful. Numerous times in my career I could have done with some of these. And now I know who makes them. Well, I know who fucking makes them, just never been asked to get it because I'm a lazy bastard. But yeah, there you go. If you want to put some end line resistance like a fire alarm panel nicely, or on some sort of control panel, get them and off you go. They exist. I think people call them diode terminals, but they're not just for diodes, they're for everything. there you go. Let's get rid of those. It's a transformer. I like this one. I mean, I could do a whole video on transformers, and maybe one day I will, but they're just proportional winds of the cable that give out a voltage on one side to a voltage on the other. This one's quite nice. It shows the 3 individual winds. Like, you'd expect a large transformer to have that form factor, like one of the ones that's in the yellow box on site. Picture if you're on YouTube. But this one, it's got the 3 separate windings. It's clearly 3-phase. I left that earth on, look, because clearly one leg of it was tapped down to earth. And I'm not sure why. Which one's the in? So the primary's got 424, draw 38. So on this side, oh no, not on that side. Yeah, that's the primary side. That's the primary side there. So on this side, if you've got 420, you use the 1U, 1V, 1W. If you've got 400 volts, use 1UV3, 1UV3, 1UV3. Or anyway, it's on there. You use these based on the proportion of the voltage you've got. So if you had 400 volts, for example, let me have a look. Yeah, so basically you select the closest voltage you've got on your primary and put it in the corresponding terminal here with either a terminal or a spigot, which is quite nice. Again, it's Siemens, so it's quite nice, yeah. No one's buying this stuff. I don't know, just Siemens contact blocks, but yeah, I think it's Siemens one. And then you set them on close to your voltage, and on the output side, you get a secondary at 380 volts, which was what the kit it was in was on those cables there. And then some reason on that one, they've decided to earth one leg of it down, which I don't know why you do that on a 3-phase transformer, but they obviously have. That's quite common to earth one leg down, but not on a 3-phase. I don't know why they've done that. I will probably cover transformers in a separate video. Not this one. It's a bit of shit world in the minute, that. Not this one, but I will cover some transformers in a video at some point before I pack up for the year. So yeah, it's transformer. Put 1 voltage in, get another voltage out. Easy peasy. Have the amps gone up? No, they ain't. Yeah, expect to see this one in a video again soon, because it looks like a transformer with its separate wires and that, and the multi-tappings and stuff like that. It's a shame I ain't got 2 of these, because if I had 2 of them, I would crack one apart and expose the windings to show a difference, but that would definitely go in my training rigs because it demonstrates it really well. 3 phases, 3 windings. This one next. That is a Rittel. It's a temperature thing. So it's just like a thermostat for in the panel. This one is a little bit special because it's got that one, which is heating, and that one is dehumidifier. So you've got a live in. That'll be dehumidifier if it's too cold. And that'll be heating if it's not hot enough. Oh, that's weird. How have I done that? It's not hot and cold, is it? 24 volt 250. It's got a dehumidifier setting and a temperature setting. So it is just a heater. Let's have a look inside. Hang on. Confusing. The mechanism in here is so ruthlessly simple. It's ridiculous. That's just some sort of string, look. Some sort of cotton. And obviously there, look, you've got a cam. So as you wind it down, look, it can basically leave the screw. And as you put the temperature up, it basically makes a switch by pulling the tension on that, look. So it just pulls it in on a slight angle. And I'm guessing then if it gets hot, this string stretches. See how accurate it is, look. If it gets hot, that string stretches. And if it gets cold, it closes it. But that's just, I mean, look at that. It's ruthless inefficient. But what's weird about it is that that wheel is made to a very tight tolerance. That string is wound to a very tight tolerance. There's a little adjustment screw there, look, sealed with wax. But I still can't work out what kind of temperature thing it is, because that's saying to me heat. And that's saying to me water humidity, water percentage. Is that hot? I don't know. I'll have to Google it. I'll Google the partner and put it on here if I find it on YouTube. Because it's a real weird thermostat. I'm sure that's heat and I'm sure that's humidity, but I thought it was a hot and cold one when I first saw it, but it's not a hot and cold one. I think it's a heat and humidity. What that's got to do with that bit of string, I do not know about humidity, but there it is. It's an SK3118. So yeah, it's a temperature and humidity sensor, I think. Hot and cold maybe, I don't know, but that's what it is. If you've seen the panel, it looks like a thermostat, and it basically is. Oh, look at that. What the fuck is that now? Even that's fucking... Hang on a minute. This might get its own video, because look, even in there, look, there's hysteresis settings, the hot and cold settings in there. Even there, again, are ruthlessly efficient, because they can be changed with those little mechanical dials. And that's because the heating, cooling and humidity is completely understood as per mathematics, and all this stretching stuff is absolutely known. And just by putting little plastic wheels in there, you can change the settings. I mean, look at that. That's crazy things, look. Obviously, what you do is you put a screwdriver in there and just jiggle it along. That's minimum and that's maximum. That'll be to keep it in a temperature humidity range. That's bonkers. I mean, the ruthlessly simple efficiency in that. So I was looking at that, but then obviously that goes on there. Oh man, that's crazy. I don't know. I'd have to look at the instructions, but yeah. Oh, it's a percentage, look. It is just humidity, look. Percentage of humidity. So this isn't a temperature. This brings on a dryer. What the that is percent. So that's percentage of humidity. That's a humidity sensor. That's weird. I'll do a separate video on this, but I'll put the data sheet up here now if you're interested. But yeah, it's a humidity sensor. Minimum and maximum humidity as a percentage, and then it heats to dry out the humidity, and then, I don't know, air conditions. I don't know what it's connected to. I didn't see the panels before they came out, so that's a weird one. So yeah, that's a really interesting, ruthlessly efficient bit of kit that I like that. Clever. They're behind the knob, so you can't turn it to a certain level. So the lowest you can turn it down is 50, and it hits the stop. So if you want to move those dials on the back of that, you can change those, look, so it hits those stops. So you can change it because it's keyed in, it only goes in one place. So that, for example, you can't turn it higher than 90 and you can't turn it less than 80. Clever, like it. I love simple mechanical stuff like that. Next one's that. That is an emergency stop relay. These are all different. This one's got 2 channels on it. There's a little drawing on there as well, look, for you playing along at home. Yeah, so what it's saying is it's got a force contactor. What I'm going to do is I'm going to do a whole video on emergency stop. I've got some emergency stop videos on my YouTube. And the other week I was thinking about putting another emergency stop video out, and I wanted an emergency stop to demonstrate. Well, now I've got this one, so I'm going to wind up in the workshop and demonstrate it. Ironically as well, I then started doing some research into emergency stops, read a couple of documents, read a couple of books, and I went to look on YouTube at what else was available. And when I googled emergency stop, the top 2 videos were mine from incognito mode. So yeah, stay with me. I'm working on an emergency stop video. However, there are on my YouTube 2 emergency stop fault finds that are quite useful if you get into where they're all emergency stops. But bear with me, and I'll be coming back to you with a video all about emergency stops. Not much left now. This one will be, it's a Phoenix contact, which it's a signal converter. So it's got a power in. Look, you put the power into it, 24 volt. You put in something, U, voltage and current and ground. In voltage, current and ground, it sends it back out. It's got a 0, so you can adjust the 0 point and a span, so you can just put the span point. Although it looks to me like they've been filled up with shit because it's been calibrated as a power light. Looking on the side, it'll tell you which one it does. It's been set at the factory, I'm guessing, unless you can change this inside. This switch is inside, is there? Can this be calibrated inside? Looks to me like you set these dip switches to make it work from input of, say, 0 to 10, output of 0 to 24, 20. So the question is, that's been wrote on. Is the dip switches inside that you can change this with, or is this a fixed one? Let me see if I can get inside it. Don't look like I can open this up, but... So yeah, looking at it, you'd think it was factory set 0 to 10 volt, 0 to 10 volt. So it's got a 0 to 10 volt input, which it then isolates and gives a 0 to 10 volt output. So it basically acts as a barrier. Now, according to that, it's got dip switches inside. I've been caught out by these before thinking they were fixed, them in not. So what this one is, this one's taking 0 to 10 volt in and putting 0 to 10 volt out. But by setting these dip switches, which must be inside this, it's very, very thin to have stuff inside it, you can change the characteristics. If that's the case, this will be a very useful addition to a test rig that I'm building for analog values. And it'll also be useful for doing a video because I haven't got 0 to 10 volt equipment that I can use, but I can use 4 to 20 milliamp source and convert it to 0 to 10. So this might be shown in a later video, but let's have a look inside. That must have dip switches in, but it's very thin form factor to have dip switches in it. Ah, look. Tabs. Hang on a minute. Let me open this up. You're seeing for the first time me, I've cracked the tabs open, yeah? Hey, you snidey bastard. Look at that. Oh, it gets stuck there. Oh, that's it. It doesn't go any higher than that. it just comes up enough to expose those. That's absolutely fantastic. Phoenix contacted me now for making good stuff. There you go. Look, there's a signal converter. You've got a transformer, you've got a power supply there, galvanic isolation, something that creates it and something that chokes it. So yeah, you can go in or out with current basically, and all your favourite flavours, 0 to 10, 0 to 20 milliamp, 4 to 20, and 0 to 10. Any combination of ones. So yeah, very nice. That'll definitely be making a show. That's going on the analogue test rig, that is, which is going to get built to show some analogue stuff. Because up until now, I can't show analogue stuff very well because I haven't got loads of analogue instruments. But now, I only need a source that can convert it. So yeah, very nice signal converter. Don't get caught out by these dip switches. That just leaves us with these now. Now, I'll give you a clue. Most of the other stuff I've shown you, I've got a rough idea what it is. Some cases, I've got a really good idea what it is. I've fucking no idea what this is. So if I was to read that, I'd say that if you put something in 1 to 3, is that a lamp? 12 to 48 volts? I don't know what this is. No idea what it is. Not a fucking clue. That is clearly a manually moved thing like an earth bar. So you clearly unscrew that and can slide it up. I don't know. Is that saying that that's pos, that's neg, and that links them? Let's put pos and neg. Let's put 24 volts in that. See what comes out the top. Don't know if that's a good idea or not, but I'll do it. Wait 1 second. I'll fire up the power supply. I've got 2 of them anyway, in case I have to crack one open. I'm totally lost on this one. Yeah, I put 24 volts in the bottom and the lamp lights in the upper position. This one's a 110 to 230 volt one, yeah, which I'd never use. So I'm going to take that one apart and look inside. On the output, that look, when the screw's in the up position, the lamp comes on and there's no voltage on the outgoing ways. So I've just basically linked, I don't know what I've done. As you move it down, that lamp comes on, then I've no idea what this is. Not seen anything like it in my life. So GTS 76, and that's what I know. So I don't know. I'm going to open this up so you can work it out. The whole point of this video is I'm not Googling anything or looking at the data sheets. I'll just slide, oh look, on, off and P in the middle. Let me just put it into the middle, hang on. That's in the middle now and lighting no lamps up. If you put it to the bottom, it doesn't do anything. Occasionally the red light flickers on. I do not know why. And obviously in this position now the voltage is coming out, but it's coming out as 20 volts. When I'm putting 23 in, I don't fucking know. Let's crack it open and have a look. It's the last thing, and I don't know what it is. I've never seen one in my life. It might have a very specialist application, and I probably will Google the datasheet after I've made this video. But yeah, it's a mystery. I'll come back to this in another video if I actually work out what they're all interesting. But never seen anything like that in my life. What a fucking really weird way of making a switch. Don't know. It's got to be the weirdest control mark component thing I've ever seen. Yeah. What I'm guessing is positive goes through from 1 to 3. Normally goes through 1 to 3, and negative goes from 2 to 4. But you can switch it off so the current just goes through, or when you switch it on, it isolates the incoming side and shorts out the... Basically, this is the incoming side, I think, and that's the outgoing side. And when current passes through, that light comes up and it goes out. And when you shove that up, you can basically short out the outgoers. I don't fucking know. Look, it's weird, look. It's got these resistors in there. I ain't got a fucking clue it does. I'll freely admit that. I got some inkling that it earths one side of it down. Like earths the load side down informs you. But I really do not fucking know. That's definitely going to be one I'm going to have to Google. And I will come back to that component. You can see from the back, look, that basically you can have an input on something. And it can go out and through and light those lamps up. But then when you slide this, it can short out those two together. But separate from that. So it's more in common with the HV switch, where it can earth its income down, or outgoing down, than it has any LV gear I've ever seen. Real weird one, that. Never seen anything like it. Going to need a Google, and it's probably got a very specialist application, of which at this stage I do not know what. But that's it. That's the pile gone, isn't it? Yeah, that's a real weird one. Sometimes the control panel, though, I mean, this is out of a 15-year-old inverter. Sometimes you come across stuff like this you've never seen before, and you've got to work it out. Now, obviously, the weirdest bit to that is that the data numbers on the side. So if you want to Google it, you'd have to get to the side of it, take it apart. But yeah, some of them were self-explanatory. Some of them are real bastards. This one's a particular bastard. But yeah, I hope that's helped. When you go into control panel, one of those useful things you can be able to do is look around it and identify what the components are, what they're doing, so you can work out the layers within there, so you can start fault finding the right layer. But yeah, that one's still got me bamboozled. But yeah, I hope it's been useful. If I find anything else interesting about these components, I'll come back to in separate videos. And we are definitely going to do a video, try as I might, fail as I might, of putting Doom on the HMI, just for the crack. See you later. Hey! Look at that. Totally fake, look. Totally fake.